easy for us. And there are voltmeters. Okay, there's a voltmeter C, A, this is B, this is R, this is R, this is R. So as this side ideal, so what we can replace them with an open circuit. So what all the current in the circuit, it will take the path like this. So how much of current here? So let it be I1. This will be I1. This will be I1. This will be I1. Then how much of current here? Let it be I2. This will be I2. This will be I2. So let me give the some specific points.
Why, sir?
Two R. Okay, I'll change it. I'll change it. This is 2R, fine. And these are the some points A, B, and C. Let me pick up like this here. So let's do one thing. What is I1 is equal to? I1 is equal to, from the I1 should be equal to V by 3R. Similarly, I2 is also equal to, total resistance is R plus 2R, V by 3R. As they are ideal. Before, but it's asking the readings of voltmeter. So readings of voltmeter means definitely they're open circuit, but practically what's happened, though he said ideal, but still what happened, for the deflection of pointer, there'll be small current, but for the pointer to deflect, what happened, a small current has to flow. Otherwise what happened, the pointer will not deflect. You have to really come back to the basic of this one here. Ideal means we'll put open circuit, means no current. No current means where the pointer will be? Pointer will be at 0, no? For the pointer to deflect in the voltmeter, this will be really for students, really it will be a problematic for us, or you only said ideal open circuit. But you see that one, when do the pointer will deflect here? Only when some current should flow. So there should be some current IG. There should be some current through the voltmeter, through the galvanometer, then it can deflect, no? At least a small current should flow for the deflection of pointer. So practically here, a small current will be flowing through the voltmeter, though they are open circuit, but we have to assume that one. So what is the basic idea? This one, a small current flows through the voltmeters for deflection of pointers. It has to flow. Though it's a ideal means don't put open circuit. Though he said ideal. I'm just this word ideal on one side, or you should have said of 3 identical voltmeters of very high internal resistance. It should have been like this. I think at least if he has said like this, no, it should have been really possible. Now you have to ask questions, sir. In questions, if they say ideal, what we should do? Definitely in a numericals, what happen? If you put open circuit, no current flow, and moreover is asking find the deflection of voltmeter. So definitely you should assume a small current passing through it. So now is asking the reading of that one. So let me choose, this is point P. So in fact, there'll be some current flowing through the meters here. How to get that current? So rather than focusing on how to get that current, so let me use this one, nodal analysis, that is going to help us a lot. So from nodal analysis, Vp minus Va by resistance of this voltmeter plus Vp minus Vc by resistance of this voltmeter. Vp minus Vb by resistance of voltmeter. All this should be equal to 0. So therefore 3 Vp minus Va minus Vb minus Vc equal to 0. Can we calculate the potential at A and B? For that I should define 0 volt. The 0 volt, I'll define this particular thing. I need a 0 volt, no? So 0 volt, let me take this one. Can we calculate potential at A and B, C? Yes, the potential at A with respect to 0 volt, we can find out. The potential at B with respect to 0 volt. This is the 0 volt I'm picking up this one. This is very important here. So here I'll write down the loop equation. VA minus I1R minus I1R minus 0 equal to 0. What is the potential of this point? Equal to 0. Do we know I1? As I1 we know. So with this VA minus 2I1R equal to 0. So what is IR equal to? V by 3. So this will become 2V by 3. So potential of point is how much now? 2V by 3. So similarly, let's calculate potential of point C. Potential of point C, Vc minus I1R equal to 0. What is the value of I1? I1R, so this should be V by 3. Potential of point B, Vb minus I2 into 2R minus 0 equals 0. So I am choosing the path. That is a path. Vb minus I2 into 2R minus Vc 0. So this should be equal to no Vb. What is I2R? Again will be V by 3. Substituting this, all these values in the above thing, so we'll get the expression for potential. So Va is how much? 2V by 3. V by 9.
5V by 9.
5V by 9. And then can we calculate now what is the reading of voltmeter A? V capital A. Vp minus Va. The reading of different meters. Anybody value?
V by 9, V by 9,
V by 9, V by 9, V
Okay, all are
V
equal
by
to
3, sir.
2.
V by 3, sir. One is V by 3, 2 are V by 9.
Va how much? Va.
V by 9, sir.
V by 9. Vb.
V by 9.
Vc.
2V
2
by
V by
9.
3.
2V
V by
by
9, sir.
This is also V by 9, huh? Check.
2V by 9, sir. 2V by 9.
2V by 9. Yeah. The reading of okay, this so that ideal word you have to be careful. Huh? So whenever if you ask the reading of voltmeter, if they're ideal, no, you have to assume that a small current flow, there'll be some deflection. If it doesn't ask anything, like it will not ask any reading of voltmeter, and if say ideal, then you have to replace with open circuit. I think this is what we have to be alert with the numericals like that. I think if they ask you in advance, no, they will say very high resistance something word rather than saying ideal. Okay, no, I'll come to the multi-range ammeter. Before that, if there's a galvanometer, say like a 40 ohm resistance, and the value of Ig is equal to say 2 milliampere. There's a galvanometer is there. Can I connect it? See, we have made ourselves certain rule that to construct an ammeter, what will happen? We need a shunt. That one. So sometimes practically a situation arises where we may connect one resistance in parallel, another resistance in series. It can happen. I will connect this be equal to say like a 4 ohm. Let this be equal to 1 ohm. So what will happen to the range? You can definitely you can ask, sir, what is this, like you made a rule, but depending upon the requirement, no, I can change situation of like this. What will be the range of this? So Imax, I am asking you, what can be the range of this particular thing? Sir, is it an ammeter or voltmeter? I am saying that let it be ammeter. But sir, R2 a resistance in series, so this can be also voltmeter. And look at the here value. I didn't apply the voltage here, no. I just connected one resistance in parallel with the galvanometer. So this will be the shunt. So even this also will become ammeter. So we'll see for expression for Imax here. This one. So let this be Ig. So here Imax minus Ig. So as they are parallel, so Ig into G plus R2 should be equal to Imax minus G into R1. So Ig into G plus R2.
Imax 30 milliamp.
Imax equal to, yeah, let me simplify this. R2 by R1 plus Ig. Okay, there's one expression is what? We are getting this one. Anybody value Imax?
30 milliamp.
30 milliampere. We can, an ammeter can be like this also. Even with voltmeter also, I can bring that one. So what about the voltages? Suppose if I apply the voltage, that voltage should be applied this one. So here like this, what happen? A setup can be off like this. So what they do is like they'll give this resistance of this one. They'll give the resistance 4 ohm. They'll ask you, what will be the resistance I should connect here for the range to be 30 milliampere? Then you should find out the unknown value R1. They may give R1, they may give R2, anyone, they'll give the range. Or here I took R1, R2, I asked you to the range. This is also an ammeter. Huh? So don't stick on to rule that only there should not be any resistance in series. There can be some resistance in series also with the galvanometer for ammeter. Now if I increase R1, let's see that R2 is there. No, I'll increase R1. I'll make 10 ohm. So definitely, what do we expect? Range Imax. So what is that Imax? Imax is called as the range. No, it's called as range of ammeter. So if I increase the R1, so what will happen to range? Range will decrease. If I increase R2, you see here, no. So I'll put some very important conditions. You can see, R1 increases. Range what will happen? Range decreases. Imax. Maximum current what we can measure decreases. If R1 decreases, the range Imax, it decreases. If R2 increases, you can see from here, I am keeping R1 constant. If R2 is increased, then the range will increase. if R2 decreases. So what happened to range? Range will. So I do have two options now. I can control.
Sir, it should be increased, sir.
Second one, sir.
Second one, R1 decreases, Imax increases. Yeah. Okay, check this condition. Suddenly why you brought this setup? You cannot, why this particular setup you brought it. So what is the problem with the shunt, low values of shunt? No, you can see morning, we also came across 1.01 or 0.00, like that the orders will come. Manufacturing a shunt of very low resistance of order less than 1 ohm, and that to accurate value, exact value, is a very big headache. To overcome that weapon, I'll go for this setup. So here it's quite convenient. No, I'll increase R2. If the range will increase, I'll keep R1 as it is. Because if R1 becomes 0.1 or 0.01, no, it'll be very difficult to manufacture such a low resistance that to exact value. So therefore, there's an alternative what we open. So that's why when you open the ammeters, no, not only R1, you see also some R2. The practical ammeters. This was the practical thing. It's not discussed in book. So possibility of asking. You have to be very careful. Okay, now